In this video, we're going to take a look at binding geometry. Binding geometry is the process of taking our joints or skeleton and attaching it to geometry. This will allow us to manipulate that geometry or deform the geometry based upon the joint position or rotation. Before we bind our geometry up, I want to make sure that I've named everything properly and that I don't have rotations or any type of bad transforms on either my joints or my geometry. I'm going to select my crow, and we can see everything there looks normal. Everything is at 0, and my scale is set to 1. All of that is good. And just a brief look here at my joints, we can see that they are all good as well. I have 0 for rotation, and all of my scales are at 1. And you can also see here too that we've completed the rest of that skeleton by adding joints for the legs and for the feet, and basically following the same process that we did for the body and for the wings. Looking at the wing, though, I can see that the name is set to joint 1. Now, this is Maya's default name, and it's not going to be very descriptive for our character. So I want to change the name of all of these joints for the left side and for the right side. This way it will distinguish the two. I'll be able to find them whether I'm using the outliner or the hypergraph. I won't have to guess as to what joint this actually is, as joint itself is just not very descriptive. I'm going to expand my outliner here so that I can see all of the joints in question. And a little bit of an easier way here is I can select, I'm going to hold Shift to grab both of those end joints, and then right-click inside of my outliner and choose Reveal Selected. This will automatically expand my outliner hierarchy to expose all of the joints that I need to see. Now I'm going to go through and select all of the joints for one side. And then I'll go up to the top and choose the little triangle shaped arrow there. And we'll choose Rename to bring up the Rename tool that is embedded into Maya's interface. Now it's going to automatically fill, it's going to give us a name there of the last joint selected or the last object selected. Of course, that's not what we want. So I'll highlight that, and then we can just type in the name that we actually want to use here. And I'm going to type in left_wing and hit enter. And that will automatically rename all of the joints that I have selected, and it does rename them sequentially. But it bases that sequential order off of the selection order. So we do want to make sure that we're selecting all of those objects in the proper order. Now, if you click and then Shift Select, that will grab all of the joints in the proper order. So I'm starting at the top and then clicking at the very last joint there, and Maya will automatically select those in the proper order. What we want to avoid is doing something like this, where I go through and actually select them out of order. That will give me a sequential list, but it will number them incorrectly. So again, I'm going to grab the top, hold Shift, select the bottom, and we'll go up to our rename, and we'll type in R_wing and hit enter. And then we can quickly rename all of those joints, or quickly rename a group of objects or nodes. All right, our skeleton is ready. I'll now select the skeleton, hold Shift, and select my geometry. Move up to Skin, Smooth Bind, and open the Smooth Bind options. And the first thing we have here is Bind To, and we do want to go with the joint hierarchy. Other options we have here are to selected joints or an object hierarchy. For this particular case with this character, we want the entire skeleton to be bound to our geometry. Sometimes we don't want to. Sometimes we'll just have joints in there to help us control other joints, but we don't want to have those attached to our geometry. So that's why we might choose selected joints. My next option is Bind Method. And for this, I want to choose Geodesic Voxel. And what this allows me to do is subdivide the model into voxels, and a voxel is a 3D pixel. We won't actually see any of this happen, but it will internally build a voxel representation of my geometry. Basically, think of a voxel as just a small little cube. So it's going to take that geometry and stack all these little cubes that will fit inside of there to make a representation of my model. This will then allow it to bind specifically and more accurately to the shape of my character. Next, our skinning method. I'm going to choose dual quaternion. And dual quaternion is a great binding method or skinning method that will try and preserve the volume of my geometry. This will prevent any type of sausage link kind of an effect that when you rotate a joint, the geometry actually twists and the volume goes down to 0 as it twists. With dual quaternion, it prevents that and will maintain that volume as those joints twist around. So this is going to make it look a lot better. Normalize weights. We have interactive or post effect. I'm going to leave this just as interactive. We can change this later. And the differences here is that interactive is going to update all of the weights every time we make a change, whereas post allows you to make changes to multiple vertices without having all of the weights update. Post is actually a little bit easier to work with, but we have a small amount of vertices here, so I'm not too worried. And again, we can switch back and forth between these two. So we'll just leave that as interactive. And my weight distribution, I'm going to leave that set to distance, where it's going to look at the distance of geometry, or the distance the vertices are from each joint, and weight it accordingly. Maximum influences is set to 5. This is the amount of joints that will be attached to any single vertex. We're maintaining maximum influences. In this particular case, that's not really all that important, but this would prevent it from going over 5. Removing any unused influences. We're also going to colorize our skeleton. Colorizing the skeleton just helps see which joints are bound to which vertices. And we'll see that a little bit more when we get into actually altering the weights of our character. Next, we have a fall off. And again, that fall off is going to help or be based upon this distance here. And then the last one is the resolution. And that resolution dictates how many voxels are actually going to be built in our binding method here. The higher the voxel count, the more detailed your weight distribution will be. We have a low resolution character here, so we don't really need anything that's too high. And we can see here we could go up as high as 1024. That's going to be a little bit too much. I'm going to leave it right there at the default of 256. That should be adequate enough. Now, reasons why you would want to raise that is if you have a ton of different appendages, and especially when those appendages start to get smaller. Now, our crow does have a few. He's got little toes down there, but 256 should be good enough because we don't have a whole lot of geometry there. There's not a lot of vertices that we have to deal with. There's like 4 vertices that make up a knuckle down there. So we're not too worried about getting too much detail out of our bind. If we had an extremely high resolution character and a lot more joints, we'd want to increase that resolution. The geodesic voxel binding method can take a little bit of time. I'm going to go ahead and hit apply, and it's working. And again, the first thing it's doing is reconstructing our geometry into voxels, and then it will apply the binding operations to that. The higher the resolution, the longer this process will take. That wasn't too bad. We'll hit close. And now we'll take a look. I'm going to grab a joint and rotate that. And you can see that bound pretty well. We get some pretty good deformation effects out of that. And we can even go down and let's take a look at our toes. And I'm going to select both of these joints and rotate both of them simultaneously. And we get good deformation there. One toe is not connected to the other. Everything is nice and separate. So that's all looking pretty good. Doesn't look like there's going to be too much weight changes. You can see we get a little bit of extra action there, but some of that's okay. But we might want to clean up some of these weights. But overall, we've got a pretty good bind going here. And we'll just back that up. And I just want to go back here real quick and just mention that the geodesic voxel, that can take some time. So if you're not working on a very efficient computer, you might not want to go for that option. You may want to change that binding method to either closest distance or closest in hierarchy. Both of these are going to do very well. They're not going to be as accurate as that geodesic voxel, but they may work in other circumstances. But both of those options there are super fast. And let's just undo this back. So now my character is no longer bound. And I'll just do closest in hierarchy. And we'll leave all of our other options there set to the same. And we'll choose bind skin. It happens almost instantly, so it's a lot faster. And when I rotate, you can see we get very similar results. The back of the character looks like it's deforming a bit more. Like I don't really like what's going on up there. But it's not too bad. It's still pretty clean. Whichever binding method you choose, you're going to get the same effects inside of the hypergraph. Everything will be attached in the same manner. I'm going to select our geometry and go to Options, Display, and turn on Shape Nodes. And also go back, Options, Display, Hidden Nodes. And what this is showing me here is that my crow, let's zoom up to it, has an extra node now. This is the original shape node. This basically happens because we attached any type of history to it. But in a skin cluster node, it's a little bit more important because it's keeping the original shape of our geometry. So no matter what we do to the deformations, Maya is still holding on to this guy here and keeping what the object actually looks like. And if we just check over here, we can also see that now we have a skin cluster node, and we'll switch to the attribute editor. We can see this a little bit better. We'll choose skin cluster, and there you can see my skinning method, weight distribution, maximum influences, all the things that we talked about we can change after the fact. And this is the main one here that we often change when we're cleaning up weights on our character, normalize weights. We can go interactive or post and toggle between the two.